Okay, so today we're going to be taking a look at integration by parts. This is a method of integrating which assumes that you have two integrable functions, or one integrable function and one differentiable function, multiplied by one another in the integrand of an integral, such that it might be solvable if you were able to look at both of these functions individually. So first we're going to take a look at deriving this here. Say we have a function defined g of x times f of x, and we're going to take the derivative of this function. And the derivative is going to look something like f prime of x, g of x, plus g prime of x, f of x, by the multiplicative rule of differentiation. And now we're going to integrate both sides of these with respect to x. And we're going to get something that looks like this. And the beauty of integration by parts is we can basically take one of these integrals to the other side of the equation and define our functions, because our functions have not yet been defined. G of x and f of x are still completely arbitrary at this point, so we could set them equal to anything theoretically. What we're going to do, we're going to subtract one of these integrals from this side of the equation such that we're solving for either the left or right integral that we have printed here. So what we're going to end up with is the integral of f of x, g prime of x with respect to x is equal to f of x, g of x, minus the integral of g of x, f prime of x with respect to x. And again, these functions are completely arbitrary at this point. So what we're going to do is we're going to let g of x be equal to the integral of some h of x with respect to x. And again, this is still arbitrary. But what this results in is this is the basic formula for integration by parts. Now what some people will do is, instead of having it as a function of x, they will define it as a u and a v. So you'll have the integral of u dv by dx equals u v minus the integral of v derivative of u with respect to x with respect to x. Personally, I prefer the functional notation, as it shows a little bit more clearly what's going on here. You have function f of x multiplied by function h of x. You have to integrate the h of x in both cases here. And in terms of solving this integral, you have to differentiate f of x as you multiply it by the integral of h of x. Let's take a look at this in action here. As we'll solve a very simple integral here. We'll solve x e to the x. Now, as you can see, we have two functions here. We have a function of x and we have a function of e to the x. Individually, these are both easy to integrate and easy to differentiate. However, when they're multiplied together, it's not quite as obvious how that would be solved. So what we're going to do here is we're going to let f of x be equal to x, and we'll let h of x be equal to e to the x. And looking at our formula up here, we'll see that we need to be able to take the integral of h of x, that's e to the x. It's easy to do the integral for that one. And we need to take the derivative of f of x, which is also easy to do. Therefore, I'm going to have f of x times the integral of h of x. So that'll be x times the integral of e to the x. Let's just write that over here. Very easy to integrate that one. So we'll plug that right into here then. And and subtract. Integral, once again, integral of h of x, that's e to the x, and f prime of x in this case is just equal to 1. So the derivative of x with respect to x is 1. This is with respect to x, therefore x e to the x minus e to the x. And that'll be plus some constant k, since this is an integral that doesn't have any boundaries defined. So if we want to prove that we've done this correctly, we can now take the derivative. Therefore, derivative with respect to x of x e to the x minus e to the x plus constant. It's going to be equal to e to the x plus x e to the x minus e to the x. These two will cross out with one another. We'll get x e to the x. So we can see that that definitely holds true, especially for this case. In general, if we were to take the derivative of this whole function, if we take the derivative of this, we will get f of x, h of x equals f prime of x, integral of h of x dx, plus f of x, h of x, minus this whole integral. Basically, we're taking the derivative, so therefore it's just going to be f prime of x, integral of h of x dx. These two are obviously the same, so then f of x, h of x equals f of x, h of x, which basically shows that the left and right hand side of the equation are in fact exactly the same. So this equality should hold. But yeah, that's basically integration by parts. Very simple, very quick, and can help you to solve a large variety of integration problems in mathematics. If you have any questions or comments, please feel free to leave them in the comment section down below. I try to respond as quickly as I possibly can. Thank you for watching, and have a great day.